The question is, an aqueous solution containing 7.97 grams of lead-2 nitrate is added to an aqueous solution containing 6.03 grams of potassium chloride to generate solid lead-2 chloride and potassium nitrate. So over here we balanced, the first part of the question is write the balanced equation with physical states. So we balanced the equation to look like this. PbNO3 plus KCl yields PbCl2 plus KNO3. We put 2 here, 2 and 2 here, and we get a balanced equation. Moving on to part B, what is the limiting reactant? Well, in order to find the limiting reactant, we have to see which reactant will yield the least amount of product. So the question says there's 7.97 grams of PbNO3 right? So that, according to stoichiometry, multiplied by the molar mass, you get 0.02406 moles of PbNO3, and that many moles, according to this ratio, yields 0.02406 moles of PbCl2. Then we move on to the next reactant, which is 6.03 grams of KCl. According to stoichiometry, where multiplied by the molar mass, by 1 mole over the amount of grams of molar mass, we get 0.0808 moles of KCl, which yields to 0.0404 moles of PbCl2. We're comparing these two, we see that this one is the limiting reactant because it is less. The third part of the question asks, if the percent yield is 83.8%, how many grams of precipitate were recovered? Well, we know that that according to 100% yield, this is how many moles we would get from the previous step, right? 0.02406 moles of PbCl2. But since there's an only 83.8% yield, we're going to multiply that amount of moles by 0.838, and we'll get this number, 0.0216 moles of PbCl2. Then this many moles, if we convert it to grams, gets us 5.607 grams of precipitate. Last part of the question, which is the hardest part, how many grams of the excess reactant remain? Well, let's start off with 100%. Let's assume we have 100%. Our reaction, right, we know looks like this. A ratio of 1 mole of PbNO3 to 2 moles of KCl to 1 mole of precipitate to 2 moles of KNO3. And we know according to our limiting reactant that we discovered in the step B, our limiting reactant is PbNO3, and we have 0.024 moles of that, right, as we found out before. So now, according to stoichiometry, it's a ratio of 1 to 2, so we multiply 0.024 times 2, that's how many moles of KCl we have. And then we do the same thing over here. But in reality, we know that we have an 83.8% yield. So only 83.8% is actually going to react. So since we know our excess is KCl, since we found it from step B that's what our excess is, we're going to focus only on that. 0.048 moles of KCl, according to our limiting reactant, that's how many moles of KCl we have that are going to react. But we're going to multiply that by 0.838 because that's the amount that actually reacts. It's going to get us to 0.0402 moles reacted in reality. That's how many moles actually reacted of KCl. Now, if that's how many moles we had total, right, because the question said you have 6.03 grams, and we minus 0.0402 moles that actually reacted, we end up with 0.0457 moles that are left unreacted. Converting to grams, we get 3.02 grams of KCl in excess, and that's the right answer.